Welcome back. Today we study section 4.2. This is to formally introduce nominal interest rate that somehow I did it in the last video. So today we're going to introduce this concept in a slightly more formal way and give different names that we will use later on in this chapter and also in this course. The first one is, let's introduce the name. It's called nominal pthly interest rate. Okay. Of course, we have the notation, which is I upper P. Okay. If you want to read this, the textbook put it as I upper P. So that's how you can read it. This P is usually an integer number. It tells us how many times the compounding is done in a year. So if P is 12, then you compound 12 times a year. So eventually we want to get effective monthly interest rate. So this I upper P is pretty much only for quotation purposes. Okay, so what the other notations we have? So basically, let me copy the definition. So if interest rate is compounded P times a year, we call or we say that the nominal interest rate is convertible pthly. We will see in a minute what it means by convertible pthly. Okay, we will see the meaning momentarily. So let me use this as a highlighter. So later on we will see the meaning of convertible. Okay, so how we can convert between different frequency. So I should also mention this. The nominal rate is pretty much for quotation purpose, which means in practice, if you are in any application, if you want to do any computation, you don't directly use this this nominal rate. You will need to convert it into something effective, and then we can do computation. And the way how we convert is as follows. So the effective interest rate over 1 over P, here, our unit is year, over 1 over P year is given by, let me switch to pencil, I will need to write, is I upper P divided by P. So that is a very, very important information or result. Somehow my P gets stuck. Okay, so basically once you get this quoted rate, you need to divide by the frequency to get the effective. So this is effective interest rate over 1 over P year, and usually this is a unit, right? So let's say an example. All right, so which means we want to compound 12 times a year. So which means our unit period is 1 month. Okay, and if we are quoted of I upper 12, okay, then the effective monthly interest rate is I upper 12 divided by 12. So this is the only place we pretty much need the nominal interest rate, is to convert the nominal interest rate into the corresponding interest rate per unit time. So here our unit is months. If P is, let's say, 4, we want to compound 4 times a year, then the unit would be a quarter. Then I upper 4 divided by 4 will give us the quarterly interest rate, right? So here, if we have, or not if, so it's I upper 4 divided by 4, right? Here we compound 4 times a year, then each unit time has 3 months, right, or a quarter. Okay. Of course, you can also do semi-annually. That means it's I upper 2 divided by 2, right? Depending on the value of P. So usually those are the usual case we have for P. But of course, P does not need to be a nice number, right? P can be, let's say 20, right? Then, does not correspond to any known like a time unit, right? It's not a month, it's not a week, right? It's you will need to round up to some decimal numbers, right? But in general, it can be anything, right? The theory applies to anything. So this can be applied to anything. So it does not need to be those I just mentioned. It can be really anything. So but in practice, usually we pick one of those numbers because we want the example to have practical meaning, right? In most cases, it's in monthly. Like in the United States, usually mortgage rates are quoted as compounded 12 times a year. So each month you need to pay one payment, right? So that's corresponding to this. Okay. With this in mind, we can easily get the result between the nominal interest rate and the effective interest rate. So we know this is the nominal interest rate. So 1 plus the nominal, this is nominal interest divided by P. So this would be my account value by the end of 1 over P year. Since we are at the compound interest rate, right? And if I want to go to 1 year, I need to raise the power to 2 to P times, right? So that's how I do the compounding, and this will give me the account value at 1. Right? If this is a little difficult for you to understand, you can just pick a number, right? So let's say P equals 4. So inside part is how you accumulate value over 1 quarter. If we want to know the accumulated value by the end of 1 year, we need to raise 1 quarter 4 times. 4 times. So P should be 4, right? So the power term should be 4, right? Exactly the value of P. So by definition, this should be equal to 1 plus I. Well, I is the effective interest rate a year. So, well, I is the effective annual interest rate, right? So from here, we get a relation. Let's say if I is given, so let me remove this and put this into a nice box so that you know this is an important formula. Right? This formula tells us once we know one side, we know the other. Right? So if you know I, you should know how to calculate I upper P. If you know the nominal interest rate I upper P, you should be able to apply this identity or this equality to calculate I. So it's two-way traffic. For instance, let's say we say the nominal interest rate or the 12th 12th interest rate is 6%, and I want to calculate the annual effective interest rate I, then I would be 1 plus I upper 12 divided by 12, okay, raised to the power of 12 minus 1. Okay, so it will be 1 plus 6% divided by 12 to the 12th minus 1. And if you have your calculator ready, you can do the computation and get the result. Let me get my calculator to compute. So it's 1.005 to the power of 12 minus 1, and then convert to the percentage is 6.17%. As I already mentioned, your effective interest rate will always be bigger than the, well, let's put equality, right? So because P is greater than or equal to 1, usually. Okay. Next, what we wonder is, so this result is between the effective interest rate and the pthly nominal interest rate. What if I want to get a relation between two different nominal interest rates at different frequency? So all I need to do is to repeat what I just wrote one more time. So assume M and P are different. So I have two possible choices for compounding frequency. Let's say on the left-hand side, I pick P to be, let's say 12. On the right-hand side, I can pick M to be 4. So the relation inside this box gives me the necessary mathematical result to convert from one to the other, right? So this is really straightforward. We actually have some examples. If you want, you can try. Like example 4.6. What do we have? We have biannually. So textbook use biannually. That means semi-annually. So we have the nominal interest rate. I upper 2 is 7%. So this will always be our notation, right? Well, this is the superscript denotes the compounding frequency. So it's P. So if it's biannually, it's compounded twice a year. So P is 2. Calculate the annual effective interest rate. So first of all, you want to calculate I, right? I would be 1 plus 7% divided by 2 to the second minus 1. Okay, you get the result. I leave that to you. It will be something bigger than 7. And then we want to convert to monthly. So we want to convert it to monthly. Oh, that's easy because so we do the same to 1 year. Okay. So let's assume you don't know the formula directly. So we establish an equation. I upper 12 divided by 12 and raised to power of 12. So we are trying to solve this, right? We take 1 over 12's power for both. Then what we have is so 2 over 12 is 1 over 6, right? Then you can do the rest, right? Minus 1 to the left-hand side, you get I upper 12 divided by 12, and then times by 12 on both sides, you get the equation. By the way, here you should get something smaller than 7% because the more you compound, the higher you accumulate or the faster you accumulate value in your account. So to get to the same, what is the percentage? The same 7.12% a year, you need less if you have higher compounding frequency. Okay. So here we can do the annuity calculations if you want, but pretty much things are the same. For instance, let's do example 4.7. So we convert from one interest rate to another to make sure it fits the time unit of our question. In example 4.7, determine the accumulated value at time 7 years of a payment of $30 at time 0. The nominal interest rate is 6% a year, convertible quarterly. So we want to know AV at 7. We have 30 at the beginning. We want to, so as usual, we still use I to denote the annual effective interest rate. But what's given is not I. What's given is the nominal interest rate, convertible quarterly. Right? Quarterly means P is 4. So there are 4 quarters. Sometimes you get confused. You put 3. There are 4 quarters in a year, not 3 quarters. So what you need to do is to basically repeat. Right? You will get I. Once you get I, obviously you know how to calculate the AV. Example 4.8. We want to know the present value, okay, from a payment $5,000 that is paid at time 12 years. The nominal interest rate is 8% a year, convertibly biannually. So example 4.8, what you know is I upper 2 is 8%. And you know the future value is $5,000. You want to know the present value. Okay, so basically you do discounting. You can get I first. Once you get I, you can get V. Once you get V, this is 5,000 times V to the power of 12. Right. So I leave that to you. That is section 3, section 2. So let me end here, and we will continue in the next video for section 3.